Hello, and welcome back to our next topic, 11, Kinetics, Energy, and Equilibrium. Today we will be discussing collision theory, part 11.1. And our aim for today is to describe the two characteristics that make a reaction most likely to occur according to collision theory. So, kinetics involves the rates of chemical reactions. What is a chemical reaction? To refresh ourselves, this is reactants rearranging to form products. So you have the same stuff on each side of your equation, it's just rearranged. We conserve our mass, right? So you have the same amount of product as reactants. So various factors affect how fast or slow a reaction can occur. Some reactions occur quickly, like burning paper, and some occur really slowly, like rusting of metal. So what has to happen for a reaction to occur in the first place? Reactant particles must collide with each other in order for a reaction to occur. So collision theory describes how the collision must take place in order to allow for a reaction to happen. So there are two things that are necessary for reactants to make products. Collisions need to occur between the particles to produce a reaction and products. But this will only happen if the spatial orientation of reactant particles is correct. So that means they have to be oriented correctly in order to crash into each other. And there has to be enough energy to allow for the reaction to occur. So if you think about it, there's collisions happening all the time. In the air right now, we've got nitrogen particles, we've got oxygen particles, we've got carbon dioxide and other miscellaneous particles in the air, and they're bumping into each other, but we don't see any reactions happening. Why? Because there's not enough energy to create a reaction, and most likely they're not also lined up just right to bump into each other at the right rate of speed and energy. So what is an effective collision? An effective collision means that the collision occurs with the correct orientation of the particles, they're lined up just right, and enough energy to form the products. So they have to bump into each other with just the right amount of energy. And this needs energy and correct orientation. So what it's an ineffective collision means that you are missing one of those pieces. Okay, a collision can occur, but the arrangement of the reactants is not correct, or there's not enough energy to allow the formation of products. So right now in the air, nitrogen and oxygen can be crashing into each other, but they are not bumping with enough energy or the right alignment to create another product in the atmosphere. So you're missing one thing or the other for an ineffective collision. For a reaction to occur, the reactants need enough energy to collide effectively. As reactant particles approach each other, kinetic energy is converted into potential energy. So kinetic energy is the motion, right? The energy of motion, and potential is stored. So it converts into potential as they approach each other. And again, the energy of motion, kinetic, has to equal the stored energy or potential at that point as they approach. The reactants also must properly be positioned in space for a reaction to occur. Proper orientation allows for that reaction to occur. If not the proper orientation, no reaction will occur. So a couple of Regents questions. In order for a chemical reaction to occur, there must always be, take a look at your choices, an effective collision between reactant particles, a bond that breaks in a reactant particle, reacting particles with a high charge, or reactant particles with high kinetic energy. This is choice 1. For a reaction to occur, you need an effective collision between particles. Effective collision means enough energy and correct orientation. As the number of effective collisions between reactant particles increases, the rate of reaction, so if you increase the amount of effective collisions, you're also going to increase the rate of reaction. So this would be choice 2. And that is it for today. See you next time.